This is how physics applies to the skill being demonstrated. Newton's first law of motion states, an object at rest stays at rest, and an object in motion stays in motion with the same speed unless acted upon by an unbalanced force. In order to start a back tuck, the gymnast must push off the ground. This is the external force that will get her moving. But she needs energy to jump. The energy to do this is obtained by her leg muscles, which is related to potential energy and kinetic energy. When her muscles contract before she jumps, they have energy stored in them, which is known as potential energy. Think of her legs as a spring that is being compressed. Then, when her muscles expand to jump, the potential energy is converted to kinetic energy, which is the energy of motion. Newton's second law of motion states that the acceleration of an object is dependent upon two variables, the net force acting upon the object and the mass of the object. To get enough acceleration to do a standing tuck, the gymnast must push off the ground with a force that is greater than her normal force, which is her mass. This gives her the acceleration to perform the skill. This applies to any skill in gymnastics that requires pushing off the ground. Here is another example. Newton's third law of motion states that every action has an equal and opposite reaction. When the gymnast pushes down on the floor before she jumps into the air, the floor pushes her back up with an equal amount of force, providing the lift she needs to flip all the way around before landing again. Angular velocity is how fast an object is rotating per unit of time. In a front tuck, the gymnast's arms maximize the angular velocity when he swings them up and over his head as he jumps. This is the moment his rotation begins. An object's angular velocity increases if there is less distance between its center of mass and the end of its radius. In other words, the less spread out an object's mass is, the faster it rotates. The smaller the gymnast makes himself, the faster he will rotate. This is why a gymnast tucks in a front flip. This decreases the distance of his radius from his center of mass, thus making him rotate faster, enabling him to flip all the way around before hitting the ground.